Okay, well, on part B of this question here, we've been given this demand function here for good Z. PZ is the price of good Z. PW is the price of the related good. M is the income. A is the advertising. Okay. The other information they've given us, PZ equals 40, PW equals 60, and M equals 30, and A equals 100 kwacha. So on part 2, determine the cross price elasticity between good Z and good W and state whether the goods are substitutes or complements. So cross price elasticity of demand, how the quantity demanded of one good is affected by the price of another good. Okay, yes. So to get our cross price elasticity of demand, okay, this is the formula. You get the partial derivative of your demand function over the partial derivative. Basically, we're saying we're deriving our demand function partially with respect to PW, because PW is the price of the other good. Okay, so we're deriving our function, demand function, with respect to PW, multiplied by PW over Q. Okay, this is the cross price elasticity of demand formula. Okay, as I said, first things first, you calculate Q. We already calculated, okay, using these values: PZ 40, PW 60, M 30,000, and A 100. So we've already calculated Q. Okay, here Q, we substituted those values in our demand function, and Q equals 394. Okay, so Q, once you've calculated it, it will just stay the same for all the elasticities. Now what we need to do is derive our demand function with respect to PZ. PW, meaning any number that doesn't have a PW disappears. Okay, 5 doesn't have a PW. Negative 0.25 doesn't have a PW. 0.03 doesn't have a PW. A doesn't have a PW. So we're deriving this 1.5 PW. So as I said, the trick, just remove the PW and your answer is 1.5 here. But let me show you how we also get the same 1.5. Right? This PW is to the power 1. Okay, whenever you're deriving, multiply the exponent with the coefficient, which is the number in front of the letter. 1 times 1.5, 1.5. After you multiply the exponent, subtract a 1 from the exponent, always. 1 minus 1, that is 0. So that we've got PW to the power 0. Okay, and anything to the power 0 is the same as 1. Okay, yes. So once we've got our values, okay, here we substitute this partial derivative of QZ with respect to PW, substitute to 1.5 multiplied by PW. In the question they told us is PW is 60, so you're going to say 60 divided by Q is 394. Okay. 60 divided by 394. 0.152, 0.152 multiplied by 1.5, you get 0.228. Okay. So since this value is positive, okay, this value here we've got is a positive value. So we can say that PW and PZ are substitutes. Okay. And if we come back to our demand function here, where is our demand function? Yes. If we look at the relationship between the quantity demanded for good Z and the price of the other good, holding other factors constant, so these holding these constant. Because of this positive sign, okay, if the price of PW goes up, the price of the other good goes up. Okay, it means this good W is going to be more expensive than good Z. So people buy more of good Z, which will translate to the quantity demanded of good Z going up. Okay. This plus sign is illustrating a positive relationship, meaning when one variable goes up, the other variable goes up. If one variable goes down, the other variable goes down. So if the price of good W goes down, good W becomes cheaper than good Z, meaning people buy more of good W and the quantity demanded for good Z is going to go down. Any questions?